All right, so our recording today is going to be super short. I just basically want to go ahead and do one additional problem from the notes last week. Yes, do you have your match? Okay, just go ahead and kind of remind ourselves of what we were doing. We were graphing logarithms, whether it's a growth or a decay base. So we'll go ahead and do one more problem to remember all those characteristics. And then tomorrow afternoon, when I go ahead and see you, we'll go ahead and finish that up. And then later in the week on Wednesday, we'll go ahead and start solving equations with logarithms in them. Okay. And in fact, Wednesday is the last day I'm going to see you this week because remember, Thursday afternoon is 5 through 8 after the testing. And then you have a long weekend. You don't come in Friday or Monday. So it's going to be awesome. Okay, so let's go ahead and go straight to this so we can go ahead and get it done. Did anybody need a copy of the notes? I do have extra copies if anybody needs one. Okay, it looks just like this. Logarithmic parent function. Okay, copy the notes. Okay. No. They look just like this. Yeah, coming from 2204. You put in your number, right? Yeah, there you go. Now go into the restroom, and let's choose second girls. You're good to go. Okay. Anybody else need a copy of the notes? Here we go. Here we go. All right. Well, this is what we started taking a look at on Friday, how to graph a logarithmic parent. And just like exponentials, we were talking about the fact that a logarithm, it can have either a growth base or it can have a decay base. So here on the left, this right here, okay, your logarithm is going to curve up to the right if it's a growth base. If the base is greater than 1, it's a decay base if your base is between 0 and 1. So notice it's going to curve down from its asymptote to the right. Now the thing about logarithms, they're always going to have a vertical asymptote. It always starts on the y-axis. The only transformation that can move that is going to be a horizontal shift. Okay, so one aspect about logarithms is that they will always be infinitely tall. And then we started looking at how to graph these, but we were kind of doing these in a little different strategy. We were using the base to create an inverse exponential. So we were getting the points from the exponential, and then we were inverting it back to a log. Okay, just like this one yesterday or on Friday, we wanted log base 2 of x. So we went ahead and found points for 2 to the x, and then we simply reversed all those points, and that's how I got my graph. Same thing as what we did with number 2. We had a base of 1/3, so I found points for 1/3 to the x. Then we went ahead and switched those. I got my points for log base 1/3 of x. Okay, so pretty easy, pretty straightforward. But let's go ahead and try one more of these. Let's see what you think. Okay, so number 3, we want to graph log base 4 of x minus 1. So in the very beginning, don't worry about any of the transformations. Just focus on your base. So here are my x's that I'm going to plug in, -2, -1, 0, 1, 2. But because my base is 4, we're going to start with the exponential 4 to the x. Okay. Remember, I'm going to get my log points by first getting the exponential points. So this is going to be pretty easy. What's 4 squared? 16. 4 to the first is 4. What's 4 to the 0? 1. Now, what happens if I raise 4 to a negative power? There you go. Remember, we make a negative power positive by taking the reciprocal. So this would be 1/4. So if I had 4 to the -2, that's 1 over 4 squared. So now 1/16. There we go. Now, this is for the exponential 4 to the x, but I want log base 4 of x. So that's where my second T-chart comes in. So log base 4 of x. Now, there is a transformation here, but we're not ready to apply it yet. All I'm going to do is take these exponential points, and I'm going to go ahead and swap them. Those are now going to be points on my logarithm. So this should be 1/16 -2. Then I should have 1/4 -1, 1, 0, 4, 1, and then 16, 2. Okay. Now, if all we were graphing was just log base 4 of x, we'd have our points and we'd be ready to go. Once you've got the log points after you've switched them from the exponential, this is when you start looking at any transformations. Now, we know that's going to shift it to the right, correct? Now we know it's to the right because we always take the what? Take the opposite. So when you are shifting horizontally, algebraically, you want to do what you would think. Because we're shifting it to the right, that means for my x's, I'm going to add 1. You'll notice there is nothing happening vertically. Nothing's going to happen to those y values. They are going to stay exactly the same. So this is -2, -1, 0, 1, 2. But what's 16 plus 1? 17. 4 plus 1 is 5. 1 plus 1 is 2. Now, let's go ahead and change these to a decimal. 1/4 is 0.25. So that would be a 1.25. And let's see what 1/16 is. So I'm going to come on over here to my calculator. 1 divided by 16. That is not what I wanted. 1 divided by 16. Let's put a point there. So I'm getting 0.0625. So if I add 1, 1.0625. So now I've got points on the actual function that I want. Here's log base 4 of x minus 1. Okay, so we're going to start with the exponential. We're going to switch those, and then we'll apply any transformations that we see. Okay. Now remember, every log parent, doesn't matter if it's a growth or decay, always starts with its asymptote on the y-axis. Where should this asymptote be? Remember, how was the graph shifted? Everything was shifted to the right. Only a horizontal shift can affect this vertical asymptote. So the asymptote should be at x equals 1. Okay, let's go ahead and plot my points. So let's see here. That gives me 1.06, so that's just barely past the asymptote. -2, 1.25, -1. Then we got 2, 0. Then we got 1, 2, 3, 4, 5, 1. And then unfortunately 17, 2 is off the graph. So we should be ending up with something like this. Okay. And remember, we had a growth base, so it makes sense that my graph is rising to the right. The y values are going to be getting larger. Okay. Now, it's 11:53. We at least got the graph. We'll come in tomorrow. We'll finish this up, and we'll go ahead and do a couple more examples. Okay. Cool. But does everybody remember what we were doing last week? Okay.